I have data on demand. I have price and I have quantity sold. I also have data on total cost. I have quantity produced and total production cost. And we assume that whatever is produced is sold. In other words, supply matches demand. I'm going to develop regression line for this data and regression line for these data. I'm going to find the maximum possible price, the maximum possible sales, fixed cost, and variable cost. After finding these costs using regression analysis, I'm going to find the quantity that maximizes the total revenue, and then find the quantity that maximizes the total profit. And because the price and quantity sold have relationship with each other, therefore the total revenue and total profit curves start from low values, go and reach to a maximum, and then come back down. Therefore, beside the point that maximizes the profit, I also find two break-even points. One of them is on the left and one of them is on the right of the point that maximizes the profit. So we implement very basic concepts, but I think we can get neat observations. As I have explained, most of my tables in my PowerPoint slides are active. I can right-click and I can open the Excel file. Here is the data that I have. These are the prices that I have set, and these are quantities that I have sold. Therefore, if I come here and if I insert scatter graph, and if I draw this graph, this is how price versus quantity curve looks like. Then we are going to pass a line through this data. Here would be max possible sales, and here would be max possible price. So if I set the price equal to this value, practically I sell nothing. And if I set the price equal to 0, that is the maximum I can sell. We may assume this is a website. At most, these many people visit that website, and that would be the maximum sale. So I come here, I want to find the point that regression line intercepts y-axis. I type intercept, and as soon as I type int, intercept is also there, tab, and then it asks me what are your y values. Here my y values are my price, and then it asks us where are your x values, and quantities are my x values, and I find 175. Therefore, the maximum price for this product is $175. Indeed, in $175, we sell nothing. Then this line has a slope which comes down. By a slope, I mean when I go 1 unit in that direction, how much that curve comes down. To find that, I just copy this down. Because my reference is relative, I should go and take this one back and take this one back. Now it refers to the same cells, and then I can remove intercept and I can type slope and then enter, and therefore slope is negative 2.5. Therefore, my line will be there, and then for each unit that I go to the right, 2.5 units I come down. The next item that I want to see is how good this line matches those numbers. If those dots were completely lying on a line, R square or coefficient of determination would have come 1. If they would have been like this, such that there is no reasonable relationship between x and y, in that case, R square would have been something close to 0. We like R square close to 1. Also, we have something called R, or correlation coefficient. Correlation coefficient is square root of R square, and it's between -1 and 1. -1 is as good as 1 because it shows the relationship. We don't care about this negative. This one and this one are both good because they tell us that these dots are lying close to a line or they are spreading around. Again, R square coefficient of determination, if it is closer to 1 is better. Correlation coefficient, closer to -1 or closer to 1, they are both good. And the relationship between correlation coefficient and coefficient of determination is coefficient of determination, or R square is square of correlation coefficient. RS, and as I type that, Q also comes up, and therefore R square between these Y's and these X's, and it comes out quite nice. If I compute equal to SQRT of this one, that would be correlation coefficient, but I should also put sign of slope in front of it. So it would be equal to sine of this one multiplied by that one, and that is correlation coefficient, R or correlation coefficient. Alternatively, R and correl is already there, tab, and then my Y's and my X's. And that will give me the same thing. Standard error is equal to ST and then X and Y, STE, X and Y. And then again, what are your Y's and what are your X's? And that would be standard error or standard deviation of your forecast. Max price, obviously, it is this one. Max sales, we have an equation here that is Y equal to B0 plus B1X, or Y equal to 175 minus 2.5X, or P, which is our variable of interest, is 175 minus 2.5Q. Now, if I am looking for this point, at this point, P is equal to 0. So I have 175 minus 2.5Q Q equal to 0, that is Q equal to 175 divided by 2.5. So in order to find that Q, I have equal to 175 divided by negative of slope. And that will give me the maximum sets. So now I have all these data. I can also use this, add trend line, and click on linear. That line would be there. Display equation and display R square. Those data, I can obtain them here too, but I like this procedure better. Now I can repeat the same procedure down here. Again, I can take this data, insert, scatter graph, and I can have it this way. Now in this situation, we are looking for this line. This is fixed cost, and if I go 1 unit to the right and then above, this would be my variable cost. Again, the same procedure, equal to intercept y's and x's, and I push F4 here, and I go over there also, and I push F4 also over there, and F4 here. Now my data is locked. I have the intercept. I copy it down and down and down, and I take the intercept out and I make it slope. I take the intercept out and I make it RSQ. This one is not exactly 1. It is this one. And here, double click on it and STE of X and Y. STE of X and Y, enter. Now I have the standard error, which is standard deviation of my forecast. This one is my fixed cost, and my variable cost is this one. So I have all the data that I need. I'll go here and I type Q, and then I type here P. I want to know what price is corresponding to what quantity. So I'll come to Q. The first thing I should do, I type 0 here. Then I go right click on this corner, I come down, release it, series, please go to, for example, 75 with a step of 1, not in a row, but in a column. So those numbers are there. Now I say equal to, let's look at my demand, equal to price, and I lock it because I'm going to copy it down, plus slope, and I lock it because I'm going to copy it down, multiplied by quantity. Don't forget, this equation is price equal to B0 plus B1Q. That is equation of line showing the relationship between P and Q, which we call it the demand curve. And in this situation, we are talking about the linear demand curve. B0 here is this intercept. B1 here is this negative 2.5. So price is equal to 175 minus 2.5 times Q, and then I copy down. Now I have the relationship between price and quantity. I can mark it all, insert scatter graph. I can insert this graph. And that is the relationship between price and quantity. Now let's go and compute total revenue. Total revenue by definition is equal to price times quantity, equal to quantity multiplied by price. And then I copy it down. Now I click on this. This one is referring to price. I bring it here, so total revenue equal to PQ. Click on it. This one is talking about price. I bring it here to make it revenue, and this is my curve. My total revenue starts from a low value, goes to maximum, and then comes up. Now I go here and I type total cost. Total cost is equal to fixed cost. My fixed cost is here, and I lock it because I'm going to copy it down, plus my variable cost, and my variable cost is right here, and I lock it because I'm going to copy it down, multiplied by quantity produced, and we assume quantity produced and quantity sold are the same. And then I copy this down. Now I go here, I click on this, and I say select data, add. What curve do you want to add? I'm going to add total cost tab, and then I'm going to select my X values, which are Control Shift down, tab, and then I go and select my Y values, Control Shift down, and OK, and OK. Now I have total cost curve added to the total revenue curve. Now I go here, and total profit is equal to total revenue minus total cost, and therefore total profit is equal to total revenue, which is this one, minus total cost, which is this one. Enter, and therefore this is my total profit. Now I can go here, I can copy this, I can paste it here, I can go over there and I can delete this one, select and bring this one and make it profit, and then I can select and bring this one and make it profit. Now that is total profit. So I have my total cost curve, I have my total profit, and so on. Total revenue reaches its maximum at this point. Total profit reaches at its maximum at this point. This point and this point could be different. There is no reason that they be equal to each other. This point is a point of revenue maximization, and this point is the point of profit maximization. But interesting point is, before this point, for point of profit maximization, we have one break-even point when total profit is equal to 0, and after that point also we have another break-even point. We can find all of them using this table that I have designed here, using match and index, find minimum, find maximum, and do match and index. But I am going to use solver. I copy this and I paste it here. This is my unit, this is my price, this is my total revenue, total cost, and total profit. And I don't need that many decimal points. Go to data, go to solver. Solver comes here. I say, Mr. Solver, please look at my total revenue. Maximize it by changing quantity. So here I type total revenue. Here I type quantity sold. Solve, and I get the answer, which is 34.9999, and I don't need that many nines. 35. So that is the point which maximizes my total revenue. This point. Now I'll go, and instead of this one, I go back, data, solver, Mr. Solver, this time maximize my total profit. Again, by changing the same thing and solve it. 32. Okay? So I found 32. Now I know that the point of profit maximization is 32. Again, I go to solver. Mr. Solver, do the same thing, but instead of maximizing it, set the value equal to 0. Solve. And I find 54. I may find something different. I will explain in a minute, but I find 54. Because this is 32, so this 54 is here, which is after 32. Now I should find this one too. It is possible that I first find this one, then I should look for that one. So now I'll go again to solver. I ask Mr. Solver, do the same thing, but I add a constraint that the one that I am looking for, this value which I am looking for, should be less than 32. You have already given me the one which is greater than 32. I need the one which is less than 32. I'll go over there. Okay. Solve. And then it will give me the second break-even point. Thank you very much. You need to think we have pull learning, not push teaching. If there is anything that you didn't follow, the first person to have faith in is yourself. Rewind some parts and try to resolve your problem. The second person are your teammates. The third, your cluster mates. The fourth, our tutor. The fifth, Dr. Asef-Vaziri. But Dr. Asef-Vaziri is always available for you. Always available for you if you have a question, specific question. So you need to start. If you have stopped in step 1, you can contact me. But after I resolve your step 1, you need to go and see if you can pass step 2 and step 3. In step 4, you may find some problems. After going through the process which I told you, you can come back to me. I am always available to answer your questions, but not to just repeat the records. You need to watch the records first. Watch the record first, think about it, communicate with your teammates, with your classmates, with your tutors, and Dr. Asef. Thank you very much for attending this session.